Hello students, welcome back. Let's see. Shall we have a bit of a recap? This is a basic strategy. Denominator, parentheses, like terms. And sometimes you have just like terms and nothing else. Trivial case. Sometimes you begin from parentheses, no denominator. A little bit harder, but still elementary. Sometimes, full-blown problem, you have to start from the denominator and then going on. In that case, you have to have appropriate strategy. What was the strategy? Strategy to remove the denominator through the LCM of the denominator. And then after removing the denominator, what do you have? Typically, you have parentheses. Even for harder problems like this, same philosophy took place here. Multiply by the denominator, remove the denominator, then you have a problem that starts from here. Well, we have even harder problem here, and can we apply same kind of argument here to solve this problem? Ready? Okay, all right, let's try that. Okay, let me open up, let's see, no, not this one, not this one. Okay, this problem is good. Okay. Just a moment, please. And I moved away from my notebook, so I ended up losing a lot of nice structure. Number one, font, and then alignment, and so on forth. Okay, all right. Okay. Okay, I don't need this part. Okay, that's the solution. And then keep those in your mind to do this kind of problem. You see, you had all these numbers downstairs. Now we have some x expressions downstairs, but still you can find appropriate LCM and multiply to each term and kill it off. What is that strategic quantity that you'll have to multiply to each term? We have x minus 2 here, so something we multiply will have to kill off this x minus 2. X minus 1 here, that 2 must be annihilated. And we have the product there. So do you see that multiplying this to each term solves everything? And let me emphasize this in appropriate color. I've been using red and blue sometimes, so this time let's use green. Okay. That doesn't look very emphasized. Okay, that looks better, making it bold. So we multiplied the same quantity to each term, much like we did over here. We multiplied not 5 times 6 times 2, but there were some common factors. So just 5 times 6 and 30, that was enough, and 2 divided by 30. Basically, this was the LCM, and we multiply that LCM to each term, and then basically we cancel out all the denominators. Similar thing is going on here. We are multiplying appropriate x expression, and that strategic x expression is the product of these two that happens to be dividing this one as well. So if you simplify, what do you get? This x minus 2 down here and that x minus 2 will cancel each other out. What do we have? 3x minus 1. Are you with me here? Next, this x minus 1 up here and that x minus 1 down here will cancel each other out. This is what we are going to get from the second term. One time something doesn't change anything, so you may remove this 1 if you like. Next, x minus 1, boop, x minus 2, x minus 2. Again, they cancel each other out. All I have left is just constant 7. So what do I have? We have an equation that starts from here now. Parentheses to break off, and some like terms, and then you're going to get a solution. I'll stop here. I'll leave the rest to each student. All the hard part, getting the LCM, and then canceling out the denominator, they're all done. From parentheses, I'm leaving those to students. Oh, by the way, before killing these, please note that this technique here and that technique over there are essentially the same. We had numbers, we had x expressions, but still they're factors, they're multiples. They're same techniques. Okay, here's one more. Now, what strategic factor shall I multiply to each individual term? Well, if this had been in class, I would have got an answer by now, but I'm afraid I'll just have to live with this lack of interaction. Well, to me, it's very clear it's x minus 1. That's the only denominator, isn't it? So let's do that. Multiply by x minus 1. Multiply by x minus 1. And I just made a mistake earlier, haven't I? Leaving this part out. This time, let's not make that mistake. Okay, all right. And then, do we have cancellation? Yes, x minus 1's cancel out. We have just 3x. And then x minus 1's cancel out. We have just 3. And then we have a problem that starts from here. Shall I leave this to you? Okay, I'm going to leave this to you, but there's going to be a bit of a surprise. But that's up to the student. Okay, I'll stop here.